Hello, I wanted to go over some more Lambda functions in this video, or specifically like more uses of the Lambda function um, in this video. Uh, I wanted to show sorting in descending and ascending order, sorting closest number to a target, and then just sorting strings by length, or some other methods as to sorting strings as well that you can use. So for sorting in ascending or descending order, for all of these functions, I'm going to be using the sort method from algorithm header. For this one, first one, we're going to just focus on the nums vector that we have here. So what we're going to do is we're going to pass in nums dot begin to nums dot end. This is essentially just telling the um, sort method to just sort from the beginning of the vector until the end, until it reaches the end. Um, Now within here, we can pass in a third parameter, which would be our what's it called? Our lambda function. And just like the video before, we're gonna start off with our capture clause, our parameter list right here, and then our body of the function. Um, the only difference, real difference from uh, having like its own lambda function is that we're not assigning it like auto compare is equal to this. We're just passing in only the necessary parts of the lambda function within the sort. So now here, what we can do is within the parameter list, we can pass in two parameters. So val1, integer val2, because that's what we're using. We're using two, um, we're comparing integers. We could also use auto. If we want, it's going to auto deduce to integer anyways. But we're gonna just use int to make things clear. And within here, what we're gonna do is we're gonna do return val1 is less than val2. So what this one-liner is doing is essentially is this: if val1 is less than val2, return true, else return false, is essentially what this one-liner is doing. So this is going to be returning true or false. False. Uh, so yeah, that's essentially it for that lambda function. We could also do this as well, compare. If you don't like this and think this is a bit more complicated, um, we could call it compare, and then again, have our capture clause of the lambda function, our parameter list, and the body of the function. And within here, we could say int val1, int val2. So we're passing in two integer values into this function. And just like the within here, sort, we could just literally just copy this and paste this into here. Now this sorts in ascending order, I believe. So from lowest to highest. Let me see, where's the A? Compare ascending, and then we can literally just copy this as well, paste this, and then paste this here. Descending would be just literally just flipping this value right here. So now if we print this, print nums, and we run this, this should print in ascending order. Now, if we just flip this sign right here, this will be sorting in descending order. And if you don't like this and think this is a bit scary or too complicated to understand, you could literally just pass in the the lambda function or the name from here into the parameter list. So compare ascending. Essentially, it's just going to pass in two values into. So it's essentially doing this, just calling the function on and passing in two values directly into the lambda function. And if we run this, you see we get in ascending, and then compare descending would be descending. like that. And this also works for strings as well. So if we say std sort our current strings right here, so strings vector, I should say, dot begin, sorry, to strings dot end, we could pass in the lambda function here, and then we could say compare two strings, so std string one, std string two, string one, and then the body right here. Do by reference. And then here we can literally say within this function, it's very similar to the other two that we just did, return string one dot size is less than string two dot size. And if we run this, we could, I don't have a print function for strings. Let me just make one real quick. Copy this. Print strings. Pass vector. Yeah, okay. And then we could just call this out print our strings and then pass in strings here. So you can see that right now it's unordered. It should be Yvonne, I think coffee first, string, and then shampoo. That should be the order in ascending order. So let me do an end line right here. And if we run this, yeah, as you can see, it sorts it in ascending order by size. And now if we flip this as well, it should do descending order now. So shampoo should be first, and my name Yvonne should be last. So that's a way to do like sorting with between sizes as well. Um, Now I wanted to also show another cool thing about these lambda functions, and it is sorting to like the closest target. So with the nums vector, we're going to do it again, call sort std sort on the nums dot begin until nums dot end. And within here, we're just going to pass in the lambda, um, uh, what's it called, bro? Brackets. That's not the word I'm looking for, but we're just going to call it brackets for now. Um, and here, just like the other two functions and compare ascending and descending, we're going to pass in two integer values. And then int val2, val2, right? And then here, what we're going to do is we're going to say return, and we're going to use the absolute function from, I think this is an algorithm as well. Absolute function of ABS of value 1 minus, let's say, 10 less than STD ABS val 2 minus 10. So essentially what this function is doing is we're going to be sorting the numbers within this vector right here by whichever is closest to this target value, which is 10 right here. So what we're going to do is say, for example, we're going to pass in what are our two numbers? 2 and 32 initially, right? So here we're passing in 2 and 32 right here for this value 2. So what we're doing here within this function is we're saying take the absolute value. So let me write this down. Absolute value of our first value, which is 2 minus 10. Is this less than the absolute value of 32 minus 10? What this does next is it takes the absolute value of minus 8 is less than the absolute value of 22. Oh, and essentially just flips the sign. 8 is less than 22. This is true. So we're saying that the current value 2 is closer to our target value, which is 10. So this stays here, and then this is in the correct position as well, because obviously 32 is greater than 56. And we're just going to keep on doing these comparisons as we go down the line in the within the vector. So now if we call this function as well, um, or if we print this function now, nums, it should be sorted. Let me do an end line again. It should sort the numbers by whichever is closest to um, 10 now. And as you can see, 16, you might think like, why is 16 there? If we do, if we follow these steps, somewhere along the line, we did um, uh, ABS of 16 minus 10, right? This gives us ABS of 6. Um, what is the absolute value of 6? It's just 6. 6 is only how far away from 10? Four numbers away from 10. If we see y2 wasn't first, how far away was 2 from 10? 2 was 8. So obviously this 16 is closer to 10. And we can also do this by checking let's see what we have. Let's say 50. Which number is closest to 50? If we run this again, you can see obviously 56 is what, uh 50. 32 is what, 8, 18 digits, 18 numbers away, I think. I might be wrong. My math might be wrong. 18, and then obviously 77 is like what, almost 20 something, or 19 digits away, I think. Maybe. Yeah. So that's another cool way of using uh Lambda to like sort numbers out. Um, I think this is pretty cool. Well, I didn't know you could do this as well. Um, Now, another thing I wanted to show you was sorting strings by length. We kind of already did this up here with this. We're just going to copy this real quick. Uh, I wanted to show this as well. Instead of passing by size, we just pass the actual strings themselves. And if we do print uh, strings, let me do another end line. And we run this. What happens here is, oh, did I do this right? String, shampoo, coffee. Okay, yeah. What happens here is that this Lambda function is going to be comparing character by character within um, each string. So here, what we're doing is we're comparing S. So say, what did we pass in? I think we passed it in already sorted, right? Yeah, we passed it in already sorted. So we passed this vector right here of strings into this final sorting algorithm right here. And what we did is essentially the function is going to go character by character within each string, since we're not comparing by size anymore. Uh, so here, say we're going to pass in shampoo and string for these two initial string 1 and string 2s, right? Uh-oh. What did I say? Shampoo and then string. So we pass these two values uh, within the Lambda function. So what we're doing is when we say return string 1 and string 1 is greater than string 2, what we're doing is we're essentially going string by string and comparing the values um, the character values between each string. Sorry, I went quiet. So here, what we're saying is we're going to be comparing each one to see if they're true or false to each other, which one is like um, less than or equal to, because remember that these are like ASCII tables. Let's just say like S is equal to like 10, and then H is equal to like 5. This is wrong. I know this is wrong, but this is just an example. T is equal to like 3. I don't know. So we're going to go character by character comparing these strings, right? These characters, I mean. First, we initially compare S to S. This is true. They're equal to each other. Now we go next to H and T. We find a difference between the two strings. Um, in this case, I think T might be greater than, yeah, obviously T is greater than H. So let's just change this to 3 instead. 5. Um, so we compare this. Is string 1 greater than string 2? String 1 was shampoo. String 2 we got to T. T is greater than H because of the ASCII table. So we put string first and then shampoo next. Um, and then we keep on comparing. Essentially, we just keep on adding two string values into here and keep on doing this comparison check that I just did right here um, until it's fully sorted. So yeah, that's another little quick video of um, some uses with Lambda functions. Hope you all could have understand this, and thank y'all for watching.